Well, what up, YouTube? This is your boy Isma coming back to you with another project that I'm working on. And today I'm bringing to you the OSI model, and we will be learning about the fundamental networking framework that determines the various stages in which data is handled across the network. Without further ado, let's get started, y'all. Task 1. What is the OSI model? The OSI model, or Open System Interconnection Model, is an absolute fundamental module used in networking. This is critical. Model provides framework detecting how all network devices will send, receive, and interpret data. One of the main benefits of the OSI model is that devices can have different functions and designs on a network while communicating with other devices. Data sent across a network that follows the uniformity of the OSI model can be understood by other devices. The OSI model consists of 7 layers, which are illustrated in the diagram below. Each layer has a different set of responsibilities and is arranged from layer 7 to layer 1. At every individual layer, the data travels through specific processes take place, and a piece of information are added to this data, which is what we'll come to discuss in the upcoming tasks within this room. However, for now, we only need to understand that this process is called encapsulation and what the OSI model looks like in like the diagram. So I'm going to go ahead and go 1 through 7 going up. So at the very bottom layer we have the physical. Second, we have data link. Third, we have network. Fourth, we have transport. Fifth, we have session. Sixth, we have presentation. And at 7, we have application. Moving on to answer the question below. What does the OSI in OSI model stand for? And that is Open System Interconnection. Second question. How many layers and digits does the OSI model have? And that is 7. Third question. Sorry about that. What is the key term for when a piece of information gets added to the data? And that is encapsulation. And that concludes this portion of this segment. Now it's time to move on. Moving on to task 2. Layer 7, application. The application layer of the OSI model is the layer that you will be most familiar with. This familiarity is because the application layer is the layer in which protocol and rules are in place to determine how users should interact with a data sent or received. Everyday applications such as an email clients, browsers, or file server browsing software such as FileZilla provide a friendly graphical user interface for users to interact with data sent or received. Other protocols include DNS, Domain Name System, which is how websites addresses are translated into IP addresses. Moving on to answer the questions below. What is the name of this layer? And that is application. Second question. What is the technical term that is given to the name of the software that users interact with? And that is graphical user interface. And that concludes this part of this section. Moving on to task 4, layer 5 session. Once data has been correctly translated or formatted from the presentation layer, layer 6, the session layer, layer 5, will begin to create a connection to the other computer that the data is destined for. When a connection is established, a session is created. While this connection is active, so is the session. The session layer, layer 5, synchronizes the two computers to ensure that they are on the same page before the data is sent and received. Once these checks are in place, the session layer will begin to divide up the data sent into smaller chunks of data and begin to send these chunks packets, one at a time. This dividing up is beneficial because if the connection is lost, only chunks that weren't yet sent will have to be sent again, not the entire piece of the data. Think of it as loading a save file in the video games. What is worthy of nothing is that sessions are unique, meaning that data cannot travel over different sessions, but in fact only across each session instead. Moving on to answer the questions below. What is the name of this layer? And that is session. Second question, what is the technical term for when a connection is successfully established? That is a session. Moving on to the third question, what is the technical term for small chunks of data? And that is packets. And guys, that concludes this portion of this section, and we'll be moving on to the next one. Moreover, now moving to task 5, layer 4, transport. Layer 4 of the OSI model plays a vital part in transmitting data across a network and can be a little bit difficult to grasp. When data is sent between devices, it follows one of two different protocols that are decided based upon several factors: TCP or UDP. Let's begin with TCP, Transmission Control Protocol. Potentially hinted by the name, this protocol is designed with reliability and guarantee in mind. This protocol reserves constant connection between the two devices from the amount of time it takes for the data to be sent and received. Not only this, but TCP incorporates error checking into its design. Error checking is how TCP can guarantee that data sent from the small chunks in this session. Layer 5 has been received and reassembled in the same order. Let's summarize the advantages and disadvantages of TCP in the table below. I will start first by reading out the advantages of TCP. Guarantee the accuracy of data. Cables of synchronizing two devices to prevent each other from being flooded with data. Performs a lot of more process for reliability. Now, moving on to disadvantages of TCP. Requires a reliable connection between the two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. A slow connection can be bottlenecked. Another device as connection will be reserved on the receiving computer the whole time. TCP is slightly slower than UDP because more work has to be done by the devices using this protocol. TCP is used for situations such as file sharing, internet browsing, or sending an email. This usage is because these services require the data to be accurate and complete. No good having half a file. In the diagram below, we can see how a picture of a cat is broken down into small pieces of data, known as packets, from the web server, where the computer reconstructs the picture of the cat into the correct order. And just like it says, that's exactly what it's doing. Now let's move on to the User Datagram Protocol, or UDP for short. This protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast the many features offered by TCP, such as error checking, and reliability. In fact, any data that gets sent via UDP is sent to the computer. Whether it gets there or not, there is no synchronization between the two devices or guarantee. Just hope for the best and fingers crossed. While this sounds disadvantageous, it does does have its merits, which we'll lay out in the table below. Advantages of UDP. UDP is much faster than TCP. UDP leaves the application layer user software to decide if there is any control over how quickly packets are sent. UDP does not reserve a continuous connection on a device as TCP does. Moving on to disadvantages of UDP. UDP doesn't care if data is received. It is quite flexible to software developers in this sense. This means that unstable connections results in a terrible experience for the user. Using the same examples as before, we can now see that only packet 1 and packet 3 have been received by the computer, meaning that half of the image is missing. UDP is useful in this situation where the small pieces of data been sent. For example, protocols used for discovering devices, ARP and DHCP, that we discussed in Room 2, Intro to LAN, or larger files such as video streaming, where it is okay if some parts of the video is pixeled. Pixels are just lost pieces of data. Moving on to answer the questions below. What is the name of this layer? And that is transport. What does TCP stand for? And that's Transmission Control Protocol. Moving on. What does UDP stand for? And that's User Datagram Protocol. Moving on now. What protocol guarantees the accuracy of data? And that is TCP. Next question. What protocol doesn't care if data is received or not by the other device? And that's UDP. Moving on. What protocol would an application such as an email client use? And that is TCP. Next question. What protocol would an application that downloads files use? And that is TCP. Moving on to the next question. What protocol would an application that streams video use? And that's UDP. And guys, that concludes this room for this chapter. I'll see you in the next one. Task 6. Layer 3 network. The third layer of the OSI model, network layer, is where the magic of routing and reassembling of data takes place. From these small chunks to the larger chunk. Firstly, routing simply determines the most optimal path in which these chunks of data should be sent, while some protocols at this layer determine exactly what is the optimal path that data should take to reach a device. We should only know about their existence at this stage of the networking module. Briefly, the protocols include OSPF, Open Shortest Path First, and RIP, Routing Information Protocol. The factors that decide what the route is taken is decided by the following. What path is the shortest? Has the least amount of devices that packets needs to travel across? What path is the most reliable? Have packets been lost on that path before? Which path has faster physical connection? Is one path using a copper connection slower or fiber considerably faster? At this layer, everything is dealt with via IP addresses, such as 192.168.1.100. Devices such as routers capable of delivering packets using IP addresses are known as layer 3 devices, because they are capable of working at the third layer of the OSI model. And here you have an example of what it's talking about. Moving on to the answer the questions below. What is the name of this layer? And that is network. Question 2. Will packets take the most optimal route across a network? And the answer is Y. Excuse me. What does the acronym OSPF stand for? It stands for Open Shortest Path First. What does the acronym RIP stand for? It stands for Routing Information Protocol. What type of addresses are dealt with at this layer? And that is IP addresses. And that concludes this portion. Moving on to task 7, layer 2, data link. The data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address for the remote computer, and adds in the physical MAC, media access control, addresses of the receiving endpoint inside every network enabled computer is a network interface card, which comes with a unique MAC address to identify it. MAC addresses are set by the manufacturer and literally burnt into the card. They can't be changed, although they can be spoofed. When information is sent across a network, it's actually the physical address that is used to identify where exactly to send the information. Additionally, it is also a job of the data link layer to present the data in a format suitable for transmission. Answer the questions below. What is the name of this layer? That's data link. Next question, it's what is the name of the piece of the hardware that all network devices come with? And that is a network interface card. That concludes this section. Moving on to task 8, layer 1, physical. This layer is one of the easiest layers to grasp. Put simply, this layer references the physical components of the hardware used in networking, and it's the lowest layer that you will find. Devices use electrical signals to transfer data between each other in binary numbering systems, ones and zeros. For example, Ethernet cables connecting devices such as in the picture below. Answer the questions below. What is the name of this layer? That is physical. What is the name of the numbering system that is both in zeros and ones? That is binary. Next question. What is the name of the cables that are used to connect devices? That is Ethernet cable. And that concludes this portion of this section. Moving on to task 9, practical OSI game. Can you escape the OSI dungeon? Climb the levels in the correct order to escape the dungeon and reveal the flag. Can you beat our staff's high score of 19 seconds? Click the view site button on the right to start. Alright guys, so we'll try to beat the 19 seconds. So let's go ahead and start, and I will be using a cheat sheet actually. So I have my cheat sheet ready, and I'm going to try to beat this in 19 seconds. So physicals first. Next is data link. Next is network. Next is transport. Next is session. Next is application. And we only did it under 34 seconds. However, we did get the flag. So go ahead and copy paste that, put it in there, and you're ready to go to task 10. Moving on to task 10. Continue your learning packets and frames. Continue your learning by joining the packets and frames room. So basically just click this and it's gonna send you to the next project that you could work on. For the answer to the question below, is just there is no answer needed, so just click complete. And congratulations, you've completed this room.